Okay, problem 8. Same idea as number 7, except now we want to make this function differentiable, but we need the same idea. The function needs to be continuous, so we need ax minus 2 to equal bx squared minus x when x equals 1. So I get a minus 2 equals b minus 1. And we also need the derivatives to be equal at x equals 1. So the derivative of ax minus 2 is simply a, and the derivative of bx squared is 2bx. But we have minus x, so it's also minus 1 there. So derivative of bx squared minus x is 2bx minus 1. And now we need to substitute 1 in for x, so we get a equals 2b minus 1. So what I'm going to do is I'm going to go to my pink equation, and I'm going to add 2 to both sides to get a equals b plus 1. And now I'm going to substitute this b plus 1 in for this a right there, because b plus 1 is equivalent to a. And so I'm going to write my equation, b plus 1 equals 2b minus 1. I'm going to solve for b, so I'm going to subtract b from both sides, and I'm going to add 1 to both sides. So I'm going to get 2 equals b. Now that I've found b, I need to take that b and substitute it back into my expression to find a. Both of my expressions are in terms of a, but if you look at this first one, I just have b plus 1. That's a little simpler to solve than 2b minus 1. I know it's clearly not much simpler to solve. They're both pretty straightforward, but I have slightly less to do. So I'm going to take that 2 and plug it in there to get a equals 2 plus 1 is 3, so a is 3. If we wanted to, we could plug it in there as well and get 2 times 2 is 4, minus 1 is 3. Either way, a is 3.